So in the last video, I introduced the theory of quantitative criticality with you. We talked about quantitative criticality. Now we're going to talk about an alternative method of calculating criticality, still quantitative, but it's an alternative, a little bit less technical alternative, by using what we call the risk priority number. The risk priority number is the product of the severity times the occurrence times the detection. And we have different rankings for severity, occurrence, and detection. The rankings are ranked numbers between 1 and 10. We're going to talk a little bit more in depth about that here in just a little bit. Generally, in order to come up with the risk priority number, a cross-section group of individuals is involved, and they come up subjectively, they come up with the ranking for severity, occurrence, and detection on that scale of 1 to 10. Then those numbers that the individual group members come up with are combined and multiplied to generate the risk priority number. The risk priority number then can be used to compare failure mode effects or compare the actual impact. So the RPN is used to compare the relative impact of a failure mode, the severity, likelihood, and ability to detect it. It helps us to determine which areas we need to prioritize to focus our efforts for risk mitigation. So let's go into each of these elements, severity, occurrence, and detection, in just a little bit more detail. This table is taken from MIL HBK 338B. There's one in your resource section of the your online learning class. As this table is an example for the severity classification. Severity is the seriousness of the effect of the potential failure. In other words, how bad would the failure mode impact the next higher component, the subsystem, system, or the customer? Will the failure, remember we're talking about the failure mode effect analysis, the FMEA, so in the failure that we're analyzing, will that failure impact other system components? If so, we identify the severity number. The severity number is on the right side of the table. We identify the severity number and we plug it into the RPM calculation. 1 and 2 down here at the bottom are minor severity. 10, 9, and 10, they are the high severity. So 10 is hazardous without warning. So the severity classification then has a ranking of 1 to 10, 1 being low severity, 10 being high severity. Your next table, also from MIL HBK 338B, provides some general guidelines for the occurrence ranking. The occurrence ranking is the likelihood of the failure cause occurring. In other words, how frequently would the system fail, or how frequently does the system fail? We identify the number that corresponds to the occurrence ranking and plug it into the RPN calculation. The rankings are on the right side of the chart again, and again, the occurrence rankings are from 1 on a scale from 1 to 10, 1 being remote, moving on up to 10, likelihood being very high. The failure rates, some examples of failure rates are given in the middle column there. Now, those are two of the three elements of the RPN calculation. And before we get into the third element, before we get into the detection ranking, we need to talk just a moment about design controls. There are 3 types of controls: type 1, 2, and 3. Type 1 control is a control that prevents the failure mode from occurring. So these are the controls that are already established in the system. They will sound similar, but please do not confuse these with hazard mitigation order of precedence. We drilled into the hazard mitigation order of precedence earlier in this course. Keep that aside in a separate compartment. These 3 control types are associated with the risk priority number, but don't confuse the 2 there. So type 1 design control is a control that will prevent the failure mode from occurring. Type 2 then is a control that detects the failure mode as imminent by identifying the cause and then leads to corrective action. So type 2 control detects the problem and corrects it, leads to corrective actions. Type 3, it detects the failure mode, but it doesn't do any mitigating or any corrective action there. So each of the three design control types, type 1, type 2, type 3, rely on detecting the failure mode prior to the actual failure. The detection ranking given for the risk priority number is based upon the reliability of that control. In other words, how reliable are these types in detecting the problem before it occurs? Here's the chart, or the table, out of the MIL HBK 338B. These are the detection ranking guidelines. It's the third and final element of the RPN calculation. And the question that we're asking ourselves here is, how likely is it that the failure will be detected before it fails? All right, 1 is almost certain. This is almost certain detection. And it progresses up through a ranking of 10. 10 is absolute uncertainty. Now, that can be perceived a little bit backwards. Notice this now again. The detection ranking, almost certain detection. Almost certain detection has a low ranking number. And absolute uncertain detection, in other words, it would not be detected until it fails, is a high ranking number 10. Keep that in mind. The risk priority number then is the product of the severity ranking, the occurrence ranking, and the detection ranking. You take in severity and occurrence, you have a priority number of 1 to 10. 10 is high, 1 is low. High severity is 10, high occurrence likelihood is 10. Low severity is 1, low occurrence likelihood is 1. In detection, 10 is low detectability. In other words, it's almost uncertain detection. And 1 for detectability is highly able to detect the failure. The next step we're going to get into is how these criticality numbers apply to the FME-CA analysis.